Okay, so what we're going to do now is review with a little question mark. Maybe you're learning it for the first time. Slope at a point. This varies a little bit from the previous video in that we were trying to find the slope over an interval, which is the average rate of change, and the slope at a point being the instantaneous rate of change. Except instead of thinking of it as rate of change now, we're going to pick on a particular function. So I'm going to be given a function. Let's start with a nice, one of my favorites, y equals e to the x. And one of the things I want you to think about, maybe not right this second, is when you're given a function, what are the advantages of being given a function as an equation versus a graph? And vice versa. When is it better to be given a graph versus a function? Which is better, and when, which circumstances make one of them better than the other? In this case, I'm going to give you a function y equals e to the x, and we want to find the slope at, say, x equals 2. Here we go. I'll start to answer that previous question a little bit for you, just to get a general idea of what that might look like. Here's e to the x, roughly. Here's 2. So what we're looking for is the slope right there. It's not a great representation of the function, but it does tell us that, okay, the slope at x equals 2, which is the slope of the tangent line at x equals 2, is some sort of positive number. It looks like it's at least more than 1. Probably my drawing's a little bit off here. E to the x is pretty steep, so we're expecting a positive number. Here we go. This is how we find the slope. Hopefully you remember some of this. I'll try not to belabor it. We're going to take the limit as h goes to 0. H is going to be some small distance away from 2 of the f. 2 plus h minus the f of 2 over 2 plus h minus 2. That's straight up definition of slope. Change in y over change in x, that is y2 minus y1 over x2 minus x1. The rest is algebra. Limit. H goes to 0. F of 2 plus h, that's e to the 2 plus h minus e to the 2 over h. What's going to happen here? No. It's exciting though. Can wrestle that around a little bit. I'm going to factor out my e squared, and I'm going to be left with e to the h minus 1. What? How'd I do that? I did it with my mad algebraic skills. Take a second and use yours. So we're left with that. Well, now what? Well, now, maybe you remember what we're going to do here is, because we can't just plug in an h because there's 0. Problem. But what we can do is go to our calculator, and what we did do is go to our calculator and plug in values for h, like 0.1, 0.01, 0.001, and so forth. And you should do that. I would recommend using the table set. And ask. Whoa, that's not even on there. And plug in those numbers. If you don't know what I'm talking about, how to use your calculator to do that efficiently, please come ask. It's pretty easy. Or email me. And I think what we find is as you plug in smaller and smaller values for h, it gets close to something like 7.3891. So that the slope is approximately 7.3891. A question which I will not answer in this video, which maybe you should answer for yourself, is what is the slope exactly? That's pretty good. That's out the 4 decimal places. We can get it to as many decimal places as we want. That'll never be exact. What is the exact slope right there? I ask you. Of course, that kind of matches our graph up here. We're expecting some sort of positive number. Obviously, my graph is not very well drawn. Two problems for you to try from here, two exercises for you to think about. One, find the tangent and normal lines. Those are y equals mx plus b lines. This is should be pretty easy. You did this on the final pretty effectively. In case you forgot, this is the tangent line. That's the normal line. Normal line is just simply perpendicular. So your answers for those are y equals mx plus b answers. You can make a sketch, verify whether you're doing it correctly, and then if you want to try another one, use the same to find the tangent and the normal lines for, say, y is equal to the sine of x at x equals pi fourths.